I want to introduce you guys with the speakers. So as I mentioned before, it's really exciting because we have the president of Decon Structural Engineering, which is Mr. Fulvio Jaramillo. So Mr. Fulvio is the president and engineering director at Decon LLC. He has more than 35 years in the bridge and structural engineering fields and is really experienced in every stage of the bridge and structural projects, from planning, initial conceptions, preliminary layouts, value engineering studies, up to structural design, budgeting, scheduling, inspection, and constructions. And today we also have Joseph Duron, which is the project manager at Decon LLC. He is really experienced in bridge substructures and also foundation design. And also he is considered knowledgeable in construction engineering and coordinates with field engineers to provide the proper corrections and solutions to construction deficiencies and modifications, which is really amazing. And last, we have Kishan Kumar, which is the graduate engineer at Decon LLC. With over a year of experience in the bridge industry, he is expanding his knowledge in the design of bridges and also highway structures. And the most important thing, he is also really skillful in MIDAS Civil and other structural analysis software. So that's why today will be really amazing, because I am sure they will share their experience and project with all of you guys, and it will be really like insightful. So right now, we all of the three speakers are already here with us. So maybe Mr. Fulvio, Joseph, Kishan, maybe you can turn on the camera and say hi to the audience. You guys are still muted right now, so I'm gonna unmute you guys so you can say hi to the audience.
Got it. So hi, everybody. Can you hear me, Tito?
Yes, I can hear you clearly, Mr. Fulvio. And I am also making you the presenter right now, so everyone can see you guys. Yes. Okay, yes. Mr. Fulvio, Joseph, Kishan, thank you so much for today. Thank you so much for being here with us, and thank you so much for hosting this webinar. I think today we have like a really high turns out. We have a lot of attendees right now. As of now, we have 139 engineers that are joining us in this session. So yeah, I think Mr. Fulvio, Joseph, Kishan, if you guys want to introduce yourself more, you can do it right now. And if you finish with that, I think we can start the presentations right away.
Sure,
Thank you so much.
Very quick, Tito, thanks again for your presentation to us, and this great opportunity to present some of the job that we're working on using MIDAS software. Hopefully it's going to be the interest of everybody. And thanks for the presentation. Next, Joseph, we are here from our offices in Houston, Texas.
Hi, I'm Joseph, I'm project manager. Again, thank you, Tito, for having us. It's actually our pleasure to be here.
Okay, so.
Hello, everyone. My name is Kishan. I'm a graduate engineer at Decon. Thank you so much for the opportunity to present whatever we have done in the project with you all guys. Thank you.
Okay, amazing. Thank you so much, guys. And also the pleasure is, it's really a pleasure to have you guys today. And thank you so much for, doing this with us and also sharing your experience with all the engineers. So Mr. Fulvio, I think right now you can share your screen. I am making you the presenter, so you can share your screen right now. So in the control panel on the right side of the screen, you can click the sharing screen, so all the attendees can see your screen.
Yeah. For some reason, I'm not getting there now.
It's fine. So if can you see the control panel on the right side of the screen? Yes, there is an option to show your screen. So if you click the sharing, you can see the drop-down options, and you just have to click the show. Can you find it?
Yeah, I'm working on that. 1 second.
Yeah, it's really fine. Take your time.
We were able to see it, yes.
Yes, right now we can see it, Mr. Fulvio. So yeah, I think you can start the presentations, and yep, it's all good right now.
It's all good?
Yes, it's all good. We can see your screen right
Yes.
now.
All right. So the project that we're going to talk about is located in Virginia. And first of all, as Tito mentioned, we are talking about analysis and design of overhead sign structures. Main credits for these presentations has to be provided to first of all, our client, the design build contractor, the developer of this project, which is FAM Construction LLC. That is Ferrovial Agroman USA. The owner of the facility is Virginia DOT. We, Decon Engineering, are the engineer of record on the project and in this particular scope, obviously. And the software that we decide to use is MIDAS Civil. And probably the special thing about this particular presentation is that, as probably most of you know, that the MIDAS Civil, the focus is not specifically for this type of structures. Is definitely is more directed to the bridge that we use, obviously, for that purpose. But we, between all the tools that we have here from our technology side to develop this particular project, we choose to go with MIDAS, and we're going to explain why. All right. So what I am having a lot of trouble here with the presentation. Sorry so much. Okay, what we have here in the outline for today, first of all, I'm gonna provide certain basic project background, general project background. Second one, we're gonna explain about the scope that we were tasked with for this particular project. Third, we're gonna talk about the definition of overhead sign structures, what we are talking about, those particular ones, the definitions. Fourth, we're going to be explaining the design criteria that we use to develop the scope, the specifications that are under the contract that we need to follow. Next, we're going to talk about the procedure, how we set up the methodology that we follow in order to get it done. Next, we're going to explain how using MIDAS Civil, we elaborate the finite element modeling of each of these structures. Next, we're going to explain how we load that model once it was set up geometrically. Then how was the process that we follow to get the structural analysis. How we next obtain then the results and our conclusions. So the project is located on the Commonwealth of Virginia in the counties of Fairfax mainly, and is the I-66. The project is called Transform 66 outside the Beltway, and as I said, it's in the counties of Fairfax, Virginia, USA. Mainly is located on the west side of the I-495 Capitol Beltway that surround Washington, D.C. This project is around $3.5 billion program that is a design build contract, and we have been working in different aspects of the project through these 3-4 years. And for this presentation, we're going to be focused specifically in this particular scope that has to do with the analysis and I would say review of the structural integrity of the existing overhead sign structures. So basically, the scope it was developed based on a requirement on the contract in technical requirements that states that the developer will, if intend to keep using some of the structures, overhead structures, sign structures that were there in the project, they need to present to develop and present a structural analysis with the new configuration of the panels for the signals that are going to be used in order to prove the feasibility to use it in obviously from the safe standpoint and the structural integrity of those elements. So we can see here in general the panel configuration generic for any of the overhead signs that we were working on, and then the intent proposed new configuration on those structures. So now I'm gonna give please Tito, give the control to Joseph, which was our project manager in this for this scope. He's gonna continue with the presentation. Please, Joseph, go ahead.
Okay, thank you so much, Mr. Fulvio, for the background of the project. So right now, Joseph, I am making you the presenter, so you can share your screen right now.
Okay. Right. Can you see my screen?
Yes, I can see your screen right now.
Okay. All right. So good afternoon or good morning, depending on where you are. So I'm the project manager. I will just go through a little bit to talk about what is overhead sign structures, the design criteria and specifications, and the procedure we use for this particular scope. Nothing fun, but we have. I think it's important to discuss this so that we can know how we reach to the final model, we'll say. So signing it's an integral part of the highway plan, and as such is developed with roadway and bridge design. Sign support structures are divided mainly into two categories. One is the road signs, and two the overhead sign structures, as you can see on your top right corner of your screen. For the purpose of this presentation, we'll be mostly focusing on the overhead sign structures. So what is overhead sign structures? It refers to structural supports for mounting signs over a roadway. They are usually built on highway traffic roads or routes with several lanes, where definitely if you have where signs posted on the side of the highway will be hard for drivers to see. There are several types of overhead sign bridges overhead sign bridges or structures used nationwide. I'll start with one on your right. This is what we call a cantilever sign bridge. Which is basically, for the most part, it consists of a 4-chord cantilever sign bridge and a 3-dimensional space frame, rigidly supported at one end by a single steel post. We have also what we call butterfly sign bridge, or sometimes known as a single pole. And this one consists of a single vertical support with horizontal members centered above the column supporting signing. We have a full span bridge, which is simply supported at each end by a single post, a 2-column support frame, or a reinforced concrete column. In the picture shown right now, this one is supported on a 2-column support frame. We're going to explore a little bit more on the components of a full span sign bridge. This is the typical, what you look at the screen right now, it's a typical overhead sign structure full span sign bridge. Generally, they're comprised of 3 components. That is the sign panel, the structure, which is the truss and the vertical supports or columns, and the foundation. We're going to discuss the design process for these elements, following specifically the AASHTO standard specification for structural support for highway signs, luminaires, and traffic signals, and specifically to the 6th edition, LTS 6, which is that one right now on your left side. That's the code that we are following. Why? Because this is what for this particular project, the owner VDOT on their bridge and roadway manual specifically tells you need to follow this code. We're going to talk about the process of loading You can see table 3.41. This is obtained from the code. The main loads in here are pretty straightforward, which are dead load, wind load, iced, and it's not on the combination, it's and live load. For the most part, as you can see, the main governing group load in this one is usually group 2, which is the dead load plus the wind load. In this kind of structure, that is the main load that governs. Speaking of the dead load, that is, it's just basically, it consists of the weight of the structure supports, the signs, luminaires, the traffic signals, lowering devices, and any other permanently item attached to the supported by the structure. Ice load, if applicable, depending on the location of your sign structure. In this case, it's Virginia, so we definitely have some ice in there. And what the code says that you should apply a load of 3 pounds per square foot around the surfaces of the structural supports, traffic signals, horizontal supports, and luminaires. And it should be considered only on one side, though, of the sign panels. Also, as mentioned previously, the live load is not there because it depends on if it's applicability. Usually, live load it's like 500 pounds, and only the members of walkway and service platforms are designed for the live load, nothing else. So that's what the code says. Then let's move on to the most important that I would say about all this load and its wind load. Because we need to know how to, for this particular project, we have to know how to load our model. We had to create an Excel spreadsheet for following the wind pressures. The wind load is the pressure of the wind acting horizontally in the supports, signs, luminaires, traffic signals, and other attachments. It consists of the equations shown on your screen. This is 3.8.3-1. Let me go over some the basics of these terms in here. Some of you might be familiar with this equation as this wind pressure equation is based on the fundamental fluid flow theory and formulations presented in the minimum design loads for buildings and other structures, ASCE 7, 1995. So the first variable that we have, KC, is the height and exposure factor, and it varies with the height above the ground depending on the local exposure conditions, and maybe conservatively set to 1 for height less than 33 feet. Then we have G, which is the gust effect factor, not to be confused with the gust coefficient. And this one shall be taken as 1.14. That is the recommendation of the code. 1.14 is the recommended for the design of structural support for all these sign structures, and this value has been designed with this. Every structure that has been designed with this value have performed well in the past, so that's the number. Then we have V. V is the basic wind speed using the determination of the design wind pressure, and it's obtained from the figure that is on the code. For this particular project and location, the basic wind speed that we used was 90 miles per hour. And then we have IR in here, which is the importance factor. This important factor, it allows the wind pressure associated with the 50-year mean recurrence interval to be adjusted to represent wind pressures associated with 10, 25, or 100 years mean recurrence intervals. The recommended minimum design life for overhead sign structure, it's 50 years, as you can see on table 3.8.3.1. So one of the things that we had to play in the model was there is a combination of loads that we need to apply. That is obviously not part of the MIDAS Civil program, but and it's basically shown on your screen. There's two cases that that the code request you to analyze the column sign structure. So in the first case, you can see the what is happening is this is for you need to apply the wind load simultaneously. The first case shows that the wind load acting normal to the sign panel, and at the same time, that full load acting normal, you need to apply a 20% transversally at the same time. And the other case is when you apply 60% or 0.6 of that wind load that is acting normal to the sign panel, you need to act simultaneously a 30% on the sign. And we will show that further down on our presentation, how we implement this into MIDAS. So once we know the code and the loading and the procedure, the design criteria and specification we need to follow, we had to determine a procedure. As Fulvio mentioned early, this is the scope is the analysis of existing sign structures, and we had to analyze these existing sign structures because they were having some modifications to the panel configuration. And this was the main process where you're looking on the screen right now. Is the main process that we follow. We obtained the as-built plans. We also had with us the original structure calculation of the existing structure. We had some inspection reports. We had some field reports as well. So what we do is we obtain those as-built plans, and we start, which were kind of tricky because they were scanned and they were dated 40 years ago, and it was kind of hard read, but we start modeling the existing structure under its current condition, and we then analyze it, and then check again the code spec checks. By then, once we compare, we have the results in our model. We compare the results with the original structure calculations to see to match, and for the most part, for all of the sign structure, not only this one that we're going to show, but all of them were in the same range. Once we feel comfortable with our model, then we create what is the modified existing sign structure model. This is the one with the different panel configuration sizes, and the geometry of the panels basically change. We repeat the same process, and we check for the new ratios or demand to capacity ratio, and from there we determine if the structure is gonna perform good under the new proposed panels configuration. So as a process, I believe after that we'll talk about the final element modeling, and for that my colleague Kishan will tell you more about it. We'll tell you about the fun stuff. So let me give you Kishan. I think I can do it from here. Change presenters.
Okay, Joseph, I will help you making Kishan the presenter.
Okay, yeah,
so
thank you, Tito.
Kishan, yes, of course, my pleasure. So Kishan, right now you are the presenter and you can share your screen right now. Yes, I can see your screen right now, Kishan. Okay, Kishan, can you say something? Because I cannot hear you.
Can you hear me?
Yes, I can. Yes, I can hear you right now. Yes, great.
Okay. Yeah. Thank you. I'll be talking about finite element modeling, load, structural analysis, and results of the project. To start with finite element modeling, this slide serves as an introduction for the terminologies of a truss, starting from the column or the upright, the column bracing, V brace, channels, struts, horizontal or vertical diagonals, or also called as top and bottom diagonals, and also the chords. The picture on the right side shows the MIDAS model. All the lines that are in blue color are the truss elements, which are which we define as truss element, and all the red lines are the beam element. And also the green plate that you can see that we used the plate element for modeling sign panels and DMS. Yeah, this is the different types of element profile that we had to define in this particular project. Because of the options that is available in MIDAS, we can define each element with customized names and all the different shapes. Elements, when it comes to elements, there are so many options that we can define an element in, like truss, tension only, compression only, plate, or solid element. In this project, we used a combination of truss, beam, and plate elements. All the diagonal elements, struts, and upright bracings, we use truss elements, and the cards and upright, we used a beam element, and we used plate element for sign panels and DMS with different thickness as per the industry standards. Let's talk about the boundaries. We provided supports at the base of each uprights. We provided a fixed support. We have an option in the MIDAS. If you go to the boundary conditions supports, if you add the boundary conditions and click all the boxes that automatically creates a fixed support, and that node basically behaves as a fixed support. The next one would be elastic rigid link that we provided to connect the sign panel bracket that you can see in the red and to the top and bottom cords. Those are the basic connection that connects the sign panel to the main truss skeleton. We have used rigid link through an option called elastic rigid link. Yeah, this one shows screenshots of a comparison between the actual plans that we got from the clients and the MIDAS model. This is actually one half of the truss in this particular sign structure. This one is the side view of upright of one side of the truss. You can see the two uprights and also the column bracings, and also the V brace and the channel and the angle seating upon which the four cords will come and sit on. The middle picture shows the MIDAS model side view of the upright, and the third picture shows you the side view of the entire truss, where you can see the sign panels and also the yellow color, that is the DMS with different thickness, and also the sign panel brackets, all the bracings, and also the bracings on the other side of the truss. This one is the front elevation of the plans of the sign structure from the plans that we got from the client. We have highlighted the sign panels with orange and DMS with yellow. You can see this is the finite element modeling that we got from MIDAS for the same structure. You can see the precision or the level of precision that we were able to achieve with MIDAS, both aesthetically and geometric wise for this particular structure. So let's talk about the loads. As mentioned earlier, we used ASTO LTS 6th edition, that is ASTO standard specifications for structural supports for highway signs, luminaires, and traffic signals. This is the screenshot from the in-house Excel sheet that we use to calculate the wind and ice load. All the factors for the wind loads, KZ, importance factor, gust effect factor, all those factors have already been discussed. So based on this code or the standard, we calculated all the loads. The first one would be dead load. MIDAS has an option called self-weight. You just have to mention which way or which direction you want the dead load to be applied. So the program calculates automatically using the material and geometric properties of the sections that you have defined previously. And the second one would be live load. As mentioned earlier, we have the code says we should apply 500 pounds of live load distributed over the 2 feet or length transversely. But this load is used only for the design of walkway members, which is out of the scope of this project. So that's the reason we have not applied live load in this structure. The third one would be ice load. The core ASTO LTS says we have 3 pounds per square foot of ice load shall be provided, shall be applied over the surface of the structural supports and all the traffic signals and horizontal supports. We have applied ice load in 2 ways, that is ice load on cords and ice load on sign panels. To apply ice load on the cords, we have used the element beam loads as an option. We apply the ice load in global Z direction, in the negative global Z direction. And we have applied ice load on sign panel using the pressure load option available on MIDAS. We have used the plate plane stress. We applied the load on the face of the sign panel in the global Z direction again. So this is a picture shows ice load on truss element. We have applied 1 pounds per feet of uniform load on all 4 cords of the truss, and also ice load on sign panel, which we have applied 3 pounds per square foot on all the exposed area of sign panel in the global Z direction. And the last one, and also the important one, would be wind load. As mentioned earlier, just like the ice load, we have 2 types of wind load. We have applied wind load in 2 ways. That is wind load on truss elements and wind load on sign panels. Wind load on truss elements, we use the same options like element beam load, just like the ice load. We use the uniform loads, and in the global Y direction, this will be the direction in the normal to the sign structure. And wind load on sign panels, we used pressure load, the same options as we used just like the ice load, and in the global Y direction. And this is the wind load clause in the ASTO LTS 3.9.3 that speaks about how do we design a structural support. It only talks about the vertical structural support. It says the sign support structure shall be designed for effects of wind from any direction, and it gives a solution on how can we do that. So on the picture on the right side, it shows WP, that is the wind load on panels. WH is the wind load on trusses, and WV would be the wind load on upright, and TC or WT is the wind load on the upright in the transverse direction. It suggests 2 cases where in the first case, you apply 100% of the wind load in the normal direction and 20% of the wind load in the transverse direction. And in the load case 2, you decrease the wind load on the normal direction to 60% and increase the transverse wind load to 30% from 20%. So this picture shows wind load on truss elements in the normal direction. You can see we have applied wind loads on each side of the truss supports, and also we have applied wind loads to the exposed truss elements in between the sign panels. All these loads are applied using the option beam element loading. And this is wind load on sign panels in the normal direction. You can see we have applied 28.1 PSF of load, which is already been calculated as per the ASTRO LTS. We have applied this in the global Y direction. This is also, we can refer to it as the normal direction of the truss. We applied all the entire throughout the exposed area of the sign panel area. And this one would be the wind load on upright in the transverse direction. So we have applied the total wind load in the global X direction. And if we come to structural analysis, we would be talking about structural analysis methodology for the analysis and methodology for the design. When it comes to analysis, as mentioned earlier, we have used ASTO LTS 6th edition. From that, we came up with load combinations On the right side, you can see all the load combinations. To be precise, we have 21 load combinations, I guess. So the first one would be group load 1, where there's only dead load, and group load 2 and group load 3, these are for the truss. These are the 4 loads that we'll be using for designing and analysis for only truss element. And from group load 2 case 1A through group load 3 case 2D, we will be using this one along with group load 1 for the analysis and design of upright or the vertical supports as per the ASTO LTS. Once we get the load combinations, we came to a conclusion for which is the critical load combination for each element profile, and we checked for axial load, whether it's tension or compression for each truss element, and for the beam element we checked the moment capacity. We also checked the deformation of the truss as a whole structure, and because of the support, the fixed support that we provide at the base of each upright, we were able to get the reactions at the base of uprights. So then next one will be design. So ASTO LTS 6th edition from clause 5.7 to 5.12 talks about the design of each element under different loading conditions. So we used in the MIDAS, we used AISC AST89 as a code because it has an option called specify allowable stresses. That means you have the freedom of defining these 0.6 or 0.33. These are the numbers which we got from the ASTO LTS 6th edition, from which I mentioned earlier, 5.7 to 5.12. It basically talks about if you are designing an element which is under axial stress, you can provide 60% of the yield strength as allowable stress. And if you are using designing for bending, you can allow 60%. If you're designing for shear stress, you can use 33% of the yield stress. This is an option that helped us in using AISC AST89. So the truss element would be checked for axial stress against the allowable stresses, and beam element would be checked for combined stresses. And this is just a screenshot of the front page, how we will get the window once we design all the elements. If it says okay, that means it has done all these checks and that element is okay, and it checks only for the critical element that is a program automated. This is the screenshot of the graphic results. This one is for the beam element and this one is for the truss element. For the beam element, we can define it checks for slenderness, axial stress, bending stresses, combined stresses, and at the end shear stresses as well. So in the truss element, it checks for slenderness, axial stress, and shear stress, as there is no bending in the truss element. And it gives out descriptive results for all the element or all the element profile that we have used. This one shows, this one actually proves the precision of our model. We were fortunate enough to get the original design calculations for the particular structures that we got from the clients when they were constructing it. So if you can see for the truss cord, the checking results, we got the combined stress ratio of 0.864. And if you can see, this is the truss cords. This is the result output from the original design. So if we do the ratio, we get 0.857. So, and for the diagonals, the same value, the same results for axial stress as it's a truss element. We check only for axial stress, which is 0.567. And the ratio here would be 0.615 from the original design. And this one is for the upright, which is again a beam element, which is 0.777 as the ratio of combined stress. And from the original design, we have 0.808. So this is about, that's all about the structural analysis. And if we talk about the results, because of the abundance of options that we had in MIDAS in producing and presenting the report, we were able to present a very descriptive and detailed report to our clients. This is one of the tables from many tables that we had in the report. This is, for example, this is the design summary for the beam element in the proposed panel arrangement condition. It gives you which structural profile, which is the element which is critical, and under which load it is critical, and what is the moment in y direction. If it's a beam element, obviously, what is the moment in y direction, what is the moment in z direction, and also the ratio. The same goes for the truss elements as well. It gives you the profile for each profile, what is the MIDAS element which is critical, for which load case it is critical, and whether it's in tension or compression, and what is the ratio for after the design, what is the ratio. This one is a cool animation for deformation in the XY direction for group load 2 case 1A, where we use 100% of the dead load and 100% of the wind load in the normal direction and 20% of the wind load in the transverse direction in this direction. This one is an animation for moment in Y direction for the same load case. You can see how the uprights on each side behaves. Yeah, and this one is a moment in Y direction for a different load case, where this one is for 100% of the dead load and 60% of the wind load, that is in the normal direction, 60% of the wind load in this direction, and 30% of the wind load in the transverse direction. This is one of the case 2 load cases. You can see the moment in each upright. So I think that's all I got. And Mr. Fulvio will be talking about the conclusions of the project. Thank you.
Okay, thank you so much, Kishan, for the explanations. So right now, Mr. Fulvio, I am making you the presenter, and now you can also share your screen.
You can see it?
Yes, I can see your screen and I can hear you right now.
Excellent, excellent. So I did it right this time. Thanks. Okay, so main conclusions about the presentation and about this project focus, obviously, in the usage of MIDAS as software. Why we, I mean, the reason we choose MIDAS Civil to model and produce all the analysis in this for this particular scope and all of these structures are summarized here. So what we found is MIDAS model the structure efficiently in both ways. I mean, aesthetically and geometrically. So the program allow us to do that model very precisely. We obtain very flexible and realistic analytical structural model. So the flexibility you could see during the presentation is that all the options that we have in MIDAS allow us to play around with different situations that these structures will be undergoing. We obtain results for individual elements in the way that we want. We customize the output of the analysis in the way that could present the comparison between the existing condition versus the future or the proposed condition, and see how feasible that will be the reusage of that structure. Through the software, we check independently the critical elements for the structural checks under different design specifications. This was a very good or very big parameter that we found very useful in MIDAS, because as you could see, we are using the structure were built several years ago and designed under very old specifications. And now the contract is a contract that lasts 3-4 years and has a specification different, obviously, time-wise. So the program allows us to produce or load the model using those specifications very accurately. So we could represent that very specifically, which is not easy in conventional softwares that are a little bit more parametric for this type of structures. We were able to depict realistic structural behavior. We use a lot the capacity of the model of the program better to show us as designers, as EORs of the project, how the structure will behave on the each load case, and determine we will be the most critical limit state that we will need to be focused on, and including deflections, including all the other stresses, so we can graphically obtain that comproval out of the software. We were able to represent results with comparison to proposed signal panel. Yes, as I already mentioned, we were able to, during the first part of the process that we follow in this type of scopes, is we at the very first at the very beginning of the project, what we do is a validation of the model compared with what the original calculations obtained, and we found very close match with what they were having originally. We were able to present the analysis and design results with actual images of the model and detailed calculations, which that helps a lot in the process of internal QA/QC, and also in all the reviews stages that a project of this size goes under for the client and for the GEC and the final facility owner. So that helps understand what is the whole process. At the end, and the most important thing, we feel very confident with the level of results and the conclusion that we obtained of the process, because everything that was treated very comprehensively due to the capacity of the software. So those are the main conclusions and benefits that we obtained choosing MIDAS Civil as a tool for produce the analytical scope on this job. So that's pretty much it, Tito, so I'll give you the word back. Thanks.
Okay. Whoa, thank you so much, Mr. Fulvio, Joseph, and also Kishan for the presentations. That was really insightful, especially for the conclusions. We are so glad that our software, MIDAS Civil, could be really useful to you guys for the project. Thank you so much. So right now, for all the attendees, we will be opening the Q&A sessions. So if you guys have any questions, just go to the right side of your screen on the control panel, and you guys can share the questions on the questions bar. So just click the questions sections, and then you can type in the questions. And also, while we are waiting for the questions, I want to ask you guys like a quick favor. So I need you guys to help us with a quick poll. It's really quick. I'm just gonna show it right now. Okay, can you guys see my screen right now?
Yes, we can.
Okay, yes, guys, please help with the quick poll. It's just like one questions. This will help us to improve our service and also improve our quality of the sessions. So for the upcoming sessions, it will be better. So just tell us, how do you feel about our service, including our webinar sessions, workshop, trainings, blogs, article, website, and all of our content, like learning content and everything. Just choose the answers, and then we can move on to the next session, which is the Q&A session. Okay, that was quick. Thank you so much. And while we are waiting for the questions, I also have a good news for all of you guys. So if you guys interested in using MIDAS Civil software, or maybe other like, MIDAS software like GTS-NX or maybe FINX, we have really good news today. So this week, we have a really special promotions for MIDAS Civil software and also other MIDAS software like FINX and GTS-NX. And I'm gonna show you guys quick information about the promotion right now. But before that, I'm gonna close the poll and thank you so much for the responses. Okay, give me a few minutes. Okay. So as I mentioned before, we have a really special promotions, both for user and non-users. So if you're users and maybe want to add additional seats or maybe want to buy more software, we also have a good promotions for you. And if you are not if you are a non-users of MIDAS software, we also have a really great special promotions for all of you guys. We have two different promotions for users and non-users. And as you can see on the screen, if you're interested in buying the software or maybe add more seats in your license, you can go to www.midasoft.com/MIDAS Platinum Package. And also the www.midasoft.com/Midas Family Program Promotions. Basically, with these promotions, you guys can save up to 30% off, which is really amazing. And on top of that, you can also get free additional license, free VINX and also GTS NX software, and free trainings and so many more. So just go to the website and learn about the promotions. And if you guys interested, just simply fill out the form on the bottom of the page. And if you guys have any having troubles with the website, you can also simply email us at grow@midasoft.com for the promotions. Just email us that you are interested in promotions, and we will contact you shortly with that. So again, for user and non-users, if you are interested in promotions, go to this website address and we will help you guys with the special promotions. Okay, I think right now the question is updated. So I will share the question slide. Okay, wait a minute. Whoa, we have a lot of questions today, which is amazing. So, okay, Mr. Fulvio, Joseph, and Kishan, I think today we have around 12 questions. So the first question is, what is the difference between truss elements and beam elements? And why were truss elements chosen for the braces instead of beam elements with pin-pin connections? Did truss elements accurately capture the out-of-plane bending on the brace elements from the wind loads? That is from Kevin A. So I think, Mr. Fulvio, Joseph, Kishan, you guys can discuss together back-to-back conversations, or maybe you can choose one person to answer the questions. It's up to you guys. Right now, you guys are unmuted. Yeah, if you want to talk, just make sure you unmute yourself.
Joseph, please go ahead.
Okay. Joseph, you are still muted. You have to unmute yourself, and then you can discuss the question.
Sorry, let me read this again. Joseph of braces.
Yes, the short answer for the first question is yes. I mean, the truss element capture accurately the out-of-plane bending on the brace elements. That is the reason why it was chosen.
Okay, thank you so much, Mr. Fulvio, for the answers. And the second question is from Ramtin K. Did you not consider fatigue?
Yes, we did consider fatigue as well. It wasn't presented as part of this presentation, but we did include fatigue as is requested by ASHTO in LTS code.
Oh, by the way, Mr. Fulvio, Joseph, and Kishan, if you guys want to, maybe go back to the presentations or share your screen, just let me know so I can make you guys the presenter. And the next question is from Dong about wind load on normal directions, y directions. The figure shows that the wind load is applied to both windward and leeward members of columns, while it is only applied to the windward truss members. Why?
No, just the presentation is not comprehensive in the way that we really load the whole model. It was just some slides showing some of the cases. It doesn't that means that we cover every single one. There were several of them. So we just follow exactly what is requested by the code in Ashton LTS. Now, by the way, in all of these, some of these questions probably deserve to a little bit deeper answer when we definitely can provide an email, just an email. We can write it down in the chat, and we can provide a more comprehensive answer for this question, because for matter of time, at this moment, it is not very feasible, but I am just providing the short answer for those. But again, the presentation is just giving some shots of the main principles behind of the modeling, but the intent was not to cover every single aspect that we covered, but it definitely is much more than what we're showing right now.
Oh, okay, that's totally okay. I think it will be amazing. And since we are also running out of time, I think we will email you the questions, and maybe you can answer the questions and share with us, and we will post it on our website. What do you think?
Sure, definitely. I mean, I can see there are very interesting questions, and we will be really happy to provide the answers from our exercise. But everything related with the formation and deflection, the criteria that we follow, how was the way to check against what was the limits that the contractually we had for being permissible in this type of a structure, and the code and so on. So yeah, definitely we'll be very happy to provide those answers. Those are very technical ones, and we'll be happy to share those with the audience.
Okay, thank you so much, Mr. Fulvio, for that. I think right now we can skip the questions, and we will be emailing the questions to Mr. Fulvio, Joseph, and Kishan, so they can share the answers, and we will post the answers on our website. And turns out right now we have 17 questions in total. Yeah, I think we don't have enough time for that. And okay, I think we can close the sessions. Mr. Fulvio, Joseph, Kishan, thank you so much for taking time to do this webinar session with us. It was really amazing presentations. It was really insightful, and I'm sure all the attendees also feel the same way. And you know, we cannot wait. We are looking forward for your next presentation with MIDAS in the upcoming months. So we are looking forward for it. And yeah, do you guys have any, maybe like, anything to say before we close the sessions?
No, we are very glad to be here and happy to collaborate and to share our experiences with all of you guys. Thanks.
Okay, thank you so much, Mr. Fulvio. Thank you so much, Joseph, and thank you so much, Kishan. And guys, one more time before we close the sessions. Again, we have the special promotions. It's very limited. It's only like, for like a very limited time. So make sure to go to this website to check out the special promotions for users and non-users, or simply email us at grow@midasoft.com. Okay, thank you so much, guys, for joining us today. Thank you so much, Decon Structural Engineering, for the great sessions. And yeah, I hope these sessions will give you guys a lot of insights and also new knowledge. And see you at the next sessions. Thank you, guys. Have a nice day.
Thank you, guys.
Thanks. Bye.